All right, thank you all for coming. My name is Dvir, and I'm going to talk about C++ add-ons for Node.js. So why I came to this subject, if you know Visual Studio Code, probably most of you do. It's an IDE from Microsoft written in a framework called Electron, which is a Node.js framework. By the way, any Node.js programmers here? Or yeah, just a couple. So I'm not a professional JavaScript developer. I'm a C++ developer. But still, I worked in this company, and we used some file format for a big data application called Parquet, which is an Apache standard. And to view it, we had some application we had to run. So in the middle of development, which I used VS Code for, I had to go out and run this application every time I wanted to look at the file. So I just wrote this extension to VS Code that simply calls that application. But then that application was deprecated and didn't support newer versions of Parquet. So I found some other JavaScript library that did about the same thing and used that. And that also got deprecated pretty soon. And so I looked at the source, the reference implementation of this protocol, and it's written in C++. So I thought, why not just use the original and call that directly? And for that, I looked how to basically call C++ from Node.js, and this is what the talk is about. So I won't do the VS Code extension this time. I thought doing something a bit more visible. So I thought I'll write this calendar application in Electron. So this is how I'd like it to be. You can enter what year you want to look at, and either the start of the week, either Sunday or Monday, and it will show you the calendar for that year. So you wrote the HTML and the JavaScript that's needed. But then all right, so how do I generate the calendar itself? And luckily last year in ACCU, I did the not so visible exactly same thing using C++ 23 ranges and stealing the idea from Eric Nibler to implement a library that generates calendars in C++. So let's just use that. So Node.js add-ons are basically shared libraries or DLLs that you can load from a Node.js application. You import them like every other Node.js module. And it has a C API, which is called the Node API. And on top of that, you have C++ wrapper, which is header only, and it's called the Node add-on API. All right, so how do you create this add-on? So at the beginning, when they started working on it, they used Jeep, which was the Chromium build system. And that is written in Python. So you basically need Python to use that. But as a C++ programmer, I usually at least for my personal projects, I like to use CMake. And also, I wanted to use C++ modules, which currently only CMake, or at least there's some build systems that support it, but CMake also does, which Jeep is not. So it turns out there's a JavaScript library that can help you with that and basically invokes CMake for a Node.js package. So as I told you, basically you need Python also for Node.js. So I thought, all right, just use also Python to install CMake. So I'm using pipenv, which is a Python virtual environment manager. The main advantage there is that I don't have to activate the virtual environment to use the whatever I install. I just do this pipenv run command, and it finds the virtual environment for me and runs that. So that's how the description file for pipenv looks like. So you can see I'm asking it to install CMake for me. All right, so every Node.js package comes with this package JSON file that describes the package. So I request this Node add-on API, which is the C++ API for Node.js add-ons. And yeah, there's also CMake.js, which I'm using, as I told. And then, whenever someone installs this package, first I'm requesting it to install, I'm requesting pipenv to install CMake, basically. And then, so just ignore this verify thing for now, but let me just scroll. Yeah, so scrolling the notes does not scroll. All right. And then I call npm run build, which basically is calling, again, I only scrolled the notes, which is calling CMake.js there. Now, every API, Node.js API has a version attached to it, which basically means what Node.js versions you will be able to use this add-on. And there's a nice table in the Node.js documentations that tells you if you use version 7, for example, that what I'm using, you will support whatever Node.js version you want. All right. To configure CMake.js, you can just pass command line arguments to it, or you can put them in this npm-rc. So npm is the package manager for Node.js. And it basically looks at this file, and you can put different configurations there. And so here I'm telling CMake where is my source, where I want the build folder to be, and I can put any CMake variable there. So, for example, I want C++23. So now I come to my CMake lists. So it's pretty standard CMake, but then I have some more work I need to do. So here I'm finding where the CMake add-on headers are, so I can include them. And also, I need to tell, to build my add-on to the appropriate API versions I'm using. So here I'm passing package JSON instead of repeating myself, or passing the package JSON to get the version. And then, again, standard CMake, I'm creating a shared library. I'm telling it where the CMake.js includes and the API is. I'm passing the version. Yeah, and there's also a library you should link to, this CMake.js lib. All right, now I'm getting to the interface of my add-on. So I'm including the Node API header. Now every add-on has this, should use this Node API module on the last line there to declare itself. And then you pass some initialization function, which is called init. Yeah. Before that, so init's job is to basically declare the interface you'll expose. Here we only have one function called generate calendar, which is basically will forward to the generate calendar function defined here. All right, so every add-on function basically has this signature. So you get some context, this info argument, and you should return an NNPI value. Then I'm checking for basically if I got the parameters I needed from the JavaScript layer. So since it's dynamic, I need to check it explicitly. So I'm checking I got what year I need to generate the calendar for and what day to start the week at. Otherwise, I'm throwing exceptions. Now, even though I'm throwing exceptions, I still has this return there because it's possible that the client will compile without exceptions, and then I don't want my function to go on. So I just return undefined value. All right, then after I verified my arguments, I can extract them. So I have the year and the start date, and then I can generate the calendar using another module, which I'll show in a minute. So this will return a range of strings in this case. So every line of the formatted calendar will be an item in this range. And finally, I'm creating a JavaScript array and copying the range to it. Since the JavaScript array doesn't have a range interface, I can't use std copy or something, so I just have a for loop, even though I do use enumerate to get the index there. All right, so as I told, the actual implementation of how to generate a calendar is in a different module, which I'm importing here. And this is the module. So don't know how many of you got to play with modules yet. First time I wrote import something, it was very exciting for me. So if you happen to use headers in your modules, you should first have this module semicolon. Then you can include some headers and then actually start your module with this export module calendar, and then you can also import other modules you depend on. So I won't go over all the details of how actually generate the calendar. As I told you, I did it last year in this conference. But I have just two functions I'm exporting out of this module. The first one takes a year where I want to generate my calendar from and returns a list of, or a range of dates. And then I have another function, format calendar, which needs the first year of the week and formats it again using range adapters. Now, skipped a slide there. One of the functions in this module needs concat view, which is not in C++23, but will probably be in 26. And so to use it, in last year's talk, I implemented it using stud generator, but that, for this, I just decided to use an external library, range v3. So I'm including it here, and then I implement concat by just delegating to range v3. But to install range v3, so again, you can just download the headers or some more, you probably know of more ways to install dependencies, but personally, I prefer using package managers. So I'm using Conan here. And since I'm already in Python land, I can just pip-env install Conan, and I got it. And to integrate Conan with CMake, there's a new CMake module you can use that supports Conan 2 and is quite recent. And you just pass, again, use this CMake variable where you pass this module to CMake, and it will include it automatically before it generates the projects. And this basically tells CMake where to find your dependencies. And then I can just, again, standard CMake, declare that my calendar module depends on range v3. You can also see the CMake syntax for compiling modules here. So you need to declare this target sources with a file set with type 6x modules and pass all your module files there. So now I like to show you it actually works. So just have VS Code open here. Sorry, I'm running a VS Code task to build the applications. You can see it calls CMake.js build there. It should already be built, so it shouldn't take long. Also, it's module, so they promised it would be fast. Actually, oh yeah, of course there's errors. Yeah, all right, so you just have to believe me in this one. Yeah, if I had more time, I would fix it. But there's other speakers waiting for the line. All right. All right, so how do you deploy this thing? Again, there's a few JavaScript packages you can use for it. So basically, unless you want your users to also build the target, the C++ code for their own platforms and force them to download the GCC and all that fun. So basically, what you want to do is to just pre-build it for each platform you would like to support. So that's basically what those packages do for you. The question is what to put those pre-built shared libraries. So you can either upload them to some web service like S3 where it downloads them from, or to GitHub releases, or just inside the NPM package, which is what package pre-builds do, and that's what I use. So yeah, to use the package pre-builds, you need to provide some description files for it. Again, you need to use the API versions, which was 7. So I'm just again including the package.json and pass it here and the name of your package. And then if you remember this line, which we ignored at first, so basically then when someone is installed your package, it runs this package pre-builds verify, and it checks that it has the required pre-built library. Otherwise, it will call the build system, and of course, it will fail unless they have the tools or for some other reason. And in CMake, I add this custom target to copy the whatever I just built to the appropriate directory where package pre-builds can find it. So again, if all this code will be published, and you'll be able to check it out later. And actually, when I call it from the JavaScript or TypeScript land, I'm using again this package pre-builds module. So and passing it the description file we just sent, so it will be able to match the pre-built library and load it. And if you use some CI pipeline like GitHub Actions, basically, as I said, you just run a build stage to build all the OSs you want to support. By the way, GitHub Actions has now free support for Mac M1 processors, which is nice. And then you do something like upload the artifacts during the specific OS you build and download them then and just combine them to one package, which you then upload to the NPM registry or whatever you use. And that's basically how you write modern C++ add-ons for Node.js. Thank you very much.